Welcome back, everyone, to this series of lectures on how to deal with missing data in a real-world data set. In part one, we're just going to simply work on evaluating what is missing, what percentage of each feature is actually missing data. Then later on, we'll work through different ways of dealing with it. As a quick note, make sure that you've already viewed the missing data lecture series in the Pandas section of the course before continuing on with this series of lectures. We've actually already had a couple of in-depth discussions on the various ways and methodologies to deal with missing data. That is, simply leaving it in, replacing it with something by filling it in, or just dropping it. And there's different ways to drop it. You can either drop rows or drop columns, and we're going to discuss that in more detail later on in this particular lecture series, especially how it affects the potential for your machine learning model. So keep in mind, make sure that you've please already have watched the missing data lectures in Pandas. We're going to be using a lot of those Pandas method calls. Okay, so working with the AIMS dataset, in particular the one that we've already dropped the outliers from, in part one we're just focusing on evaluating how much data is actually missing. Let's open up the Jupyter Notebook and get started. All right, here I am at the Jupyter Notebook. I've gone ahead and done the usual imports, and now what we want to do is actually display a feature description text file that we have for you. Whenever we're thinking about removing features or possibly filling in features, it's very important that we have kind of full understanding of what these features actually represent. And luckily, for a good data set, there should be some sort of feature description. Obviously, this depends on the situation. Not every real-world data set is going to have this nice, convenient feature description text file, but hopefully, whoever is gathering this is actually taking note of what each feature represents. Obviously, we can't help you personally if that work wasn't done beforehand. You'll have to manually figure it out yourself. But what we're going to do is underneath the data folder, there is a file called AIMS housing underscore feature, and you should be able to tab autocomplete this to see data AIMS housing feature description.txt. We're just going to read in that file. So we're opening it, mode is equal to R. This is just basic Python code. And then we're going to say as f print f.read. So for some reason you're not familiar with kind of this basic Python code, all it does is it opens up a text file in read mode, sets it to the variable f, and then it will read it in, and we're going to print out those results. The with operator allows us to essentially automatically close this file instead of holding it open even after we read it. So when I run this, and if you're doing this correctly, you should be able to see this large kind of text file printed out below, and essentially all this text file is the name of the feature, a general description of it, and then if it's categorical, what those actual categories are representing. So for example, we have a land slope feature, it's the slope of the property, and there's three categories: a gentle slope, moderate slope, or severe slope. Same for maybe there's neighborhoods here, etc. So we can see overall quality, 10 is very excellent, 1 is very poor, etc. So we have lots of features here. Now let's go ahead and read in the data. Recall in the previous lecture series, we went ahead and removed outliers. We already have a setup removed outlier CSV for you. So go ahead and say pd read CSV, and underneath the data folder, there is AIMS underscore, and we're going to open up outliers removed. I would highly recommend that you're actually using our CSV files in case you're following along, because it's very easy to make a typo. We're going to be doing a lot of operations, and we're going to keep making adjustments to this file. Be careful not to overwrite the existing files in the CSV, because if you make a typo and you overwrite one of our files, you'll have to re-download the zip again to get the original file. What you may want to do is just create a copy of the data folder somewhere else on your computer to have an original set of data files in case anything gets messed up. But what we're going to do is read this in, and I can see now df info. If you read this in and didn't overwrite it, you should be able to see it has 81 columns and 2,927 entries. Essentially, we only removed 3 rows previously. So now what we're going to do is take a look at some of these columns. Right off the bat, it's quite clear if we say df.head and check out this first PID column. This is just a unique identifier for every single row. There's actually nothing really of value here for some machine learning model to actually grab. There's not going to be a coefficient that we can apply to a unique identifier to each row, because it doesn't really have a relationship. And since we already have the index as a unique identifier, it makes sense to simply just drop PID. So in general, if you have some sort of unique ID, you should either be setting it as your index or just dropping it. Let's go ahead and just drop it. So we'll say df is equal to df.drop, and we'll say PID. Axis is equal to 1 because it's a column. And now if we check out the length of df columns, we should be able to see there's only 80 columns now. Perfect. Now it's time to actually get into what features are missing. We know that if I say df is null, it will tell me just a Boolean data frame of what is actually missing, which means I should be able to do something like this. I should be able to say df is null, take the sum of this, as we discussed in Pandas. It's going to treat falses as zeros and trues as ones. And if you run this, you essentially now have a series where it's going to report to you how many rows are you missing values for every single feature. We have 80 features, so it's not showing us everything. A couple different ways we can do this. One is to just check where is this actually positive. So then you get something that looks like this, and then we could further specify where something's true. But more importantly, what I really want to know is some sort of ratio of what's missing. It's not very helpful to me to just see, okay, I'm missing 490 lot frontage values. Is that a lot or is that a little? What might be better is to say I'm missing some percentage of all lot frontage. So instead, what we're going to say is the following. I'm going to create a function that is essentially going to report back the percentage of what is missing. So for example, I could say something like 100 times df is null.sum divided by the length of the data frame. And this would transform everything into a percentage because we're just dividing by the actual number of rows in the data frame versus how many are missing and then multiplying by 100. So I can see I'm missing 16.74% of all possible lot frontage values. Later on, we'll have to discuss whether or not that's a lot to be missing or if that's a little to be missing. Let's go ahead and create a function that essentially does this for us. I will say df %_missing df, whoops. And this way you have a function you can apply to your own data sets in the future. And we'll say %_nan is equal to what we just did up here. So I'm going to copy and paste this line. So that will copy and paste. And then what I want to do is also figure out where the percentage is actually greater than 0. I'm not super interested in things that are not missing any data for this particular case. So we'll also say %nan is equal to %nan where the percent missing, or the percent that is nan, is greater than 0. And then what I'm also going to do is sort these values. Finally, we'll return %_nan. So all we're doing here is we're essentially taking this and then further specifying only values where this is greater than 0. And we're doing this over 2 lines because it's a little more readable this way. Finally, we're also sorting it, which means you now have this function you can apply to any data set. Notice it's just generalized for df that should immediately report to you the percentages of where you're missing data. So I'll create a new variable called %nan and call it the result of %missing on our current data frame. Run that, and if you check out %nan, it should only be positive values where you're missing data. So we're obviously missing data on every single one of these features, but for some of them, we're missing a ton of rows. So 99.59% of all houses in the data set don't actually have information about pool quality. Now, that could be for 2 reasons. One is that it simply wasn't collected, or 2, nan is more of an indication of whether or not they have a pool. So maybe instead of having nan, it should just be 0 or something there. We would have to go back to that feature text document and begin to explore that further. But one other way I want to show for actually visualizing this data is to just make this into a bar plot. So we already have this very useful series. Essentially, we have to go through each one of these features and decide what to keep, what to fill, and what to drop. And we'll say sns.barplot, and I'm going to say x is equal to %nan.index. So I'm saying the x-axis should be these index values, the actual feature names, and then y is going to be equal to %nan, which are the actual corresponding values themselves. So when you create a bar plot like this, by default, it's going to not look so great. Notice that all these features are overlapping. So what we can do with Seaborn quite easily is say plt x ticks, rotation is equal to 90 degrees, and what it's going to do is it's going to rotate everything for us as far as the features. So that's just rotating this actual x tick. And now I can visually see percentage-wise, what am I missing a lot of versus what am I maybe just going to drop a few rows of data worth. Okay, so far we've evaluated what data we're actually missing. What we haven't actually done yet is decided what are we going to do about it. So there's many different strategies we're going to be working with, and we're also going to discuss when it makes sense to remove rows versus removing columns versus removing something like an entire feature set. Okay, so by now you should have been able to follow along and just seen the visualization of the percentage of data you're missing for the features where you are missing data. I'll see you at the next lecture where we begin to discuss removing features versus removing rows.